we are going to look at what's called rational exponents. Now, if you forgot what rational means, rational simply means something can be written fractionally. So I like to just put a little F in the front and a C right there. And look, it's fractional, fractional. So whenever you see rational, we think primarily fractions. So what we're going to do is simplify any expressions that have rational exponents. So first let's define something, and then I'll give you the reason, the rationale for it behind here. And this is the concept right here. If you recall right there, that this is called my index. But notice, I can rewrite that index, and here's my index again, and notice where it is, as a rational exponent. If I were to say, oh, here is a to the m power, which is the same as saying all of this to the mth power. But notice, look, a to the m power is still right there. A to the mth power is still right there. So all we're effectively doing is just taking the index and putting it as the denominator in the exponent. I'll explain why that's possible, but this is simply, it's just a matter of rewriting, moving things around a little bit. So here's the rationale for it. B to the x power is the cube root of b to the fourth power. So that means b times b, oh, actually, let me undo that one. If I were to cube this side right here in order to get rid of that index right there and cube this side right here, let me just show you what happens there. This now becomes b to the 3x equals b to the 4. Now notice that I can effectively ignore the b's because they're the same bases. So all I have to do is look at those two. Those two should be the same. So that means 3x is equal to 4. So x equals 3/4. So let me go ahead and rewrite that up here. If x is 3/4, that's this x right there. That means my original situation is b to the 3/4. Like so. So, the cube root of b to the 4th is the same thing as saying b to the 3/4. What's my mistake? Thank you. Good. It should be 3 downstairs. Hashtag. That one should be a 4/3. Good. So let me clean that up there. So made that change there? Good. So it's actually 4/3. So notice that 3 right there becomes the denominator. And the b to the 4 is still b to the 4. If you want to write your fractions like this, b to the 4/3 stacked, or b to the 4 and do a slash, 3 like that, those are totally fine. Beware, do not do this, because this means b times 4 to the 4/3. So the way it's written here is that this is actually the coefficient there and not an exponent. This is an exponent, this is an exponent. This is probably the most common, but feel free to write it like this if you don't want to adjust things to fit squashed in like that. Okay, so let's start to translate this. What do the exponents mean? Well, remember, this right here is just my root. That's all it means. It's my root. So what does this actually mean? The square root of 256. There you go. So on your calculator, you can hit the square root button, and in the end, you get 16. All right, so with that in mind, what's this one? Well, this is the cube root. That's all it means. Now, you don't have to rewrite it like this. I'm not interested right now. If you want to rewrite it, you may, but you don't have to. But if you know this cube root there is 27, you can just plug that into your calculator. You can just play with it. Notice what else I could have done here. Eyes on deck, just to see. I could have done this. 27 is 3 to the 3rd. Excuse me, 3 to the 3rd power to the 1/3 power. 3 to the 3rd to the 1/3 power. And when you multiply these, 3 times 1/3 is 1. and you end up with 3. Notice my mistake. Sorry about that. I still get 3. So it doesn't matter how you do it. What I did was convert this to a power of 3, and then I used my power of a power to multiply those exponents, and I got a 1, so my answer is 3. Or I just said, oh, it's a cube root, so I changed that to an index there, and punched it in my calculator, or just did it in my head. So here, this is just a product of powers, so the bases are the same, so all I have to do is take the 1/2 and add the 1/2, so that gives me a 1. So my answer is just 7. Or, wait, how else could I have done that? Well, I could have done it like this. The square root of 7 times the square root of 7. If you wanted to keep going, that's the square root of 49. And what's the square root of 49? 7. So it doesn't matter which direction you go. Sometimes one method is easier, depending on the context. So here you could just add the exponents together to get a 1 and simplify. Here I converted, multiplied out, and simplified. Again, whatever floats your boat. All right, now what to do, what to do, what to do. There's a couple different ways to approach this, but let me convert things like so, and then convert things like so. See if that takes me anywhere. All right, this one is a misprint, so if you can change this this 3 to a 2, so that means I'm going to delete that one. Okay, so now notice it's the square root of 3 times the square root of 75. What happens is that the 2 come together inside 1, like so. And that's 225 inside, square root. And I end up with 15, like so. That's not the only way to have done this, but there we go, I did that. The next thing we're going to do is we're going to convert from one form to another. So it's not about simplifying necessarily, it's about just converting, that's all. So notice here, this one's a very straightforward one. This is my root, so I'm going to put that as the index, and the rest of it can go inside, x to the 4th. Now, just to give you a heads up, either one of these results will be accepted as an answer. Notice if you put the 4 outside the radical or the 4 inside, that's okay. It doesn't matter which one is being quartified, if I'm quartifying the radicand or the whole radical. Both of these are acceptable. Generally, I think I'll probably be doing this with it inside. What about v, or b, v to the 1.5? Well,
Can't you just do v or 1.5 to...
So the question is, what is the 1.5 as a fraction? So that's actually not too not too difficult. Remember that 1.5 is 15 over 10. Where did that come from? Well, if I shift this over by 1 decimal, that means I'm taking it under 10. If I had to move it over 2 decimals, then I would put it over 100. So 15 over 10 actually now reduces, divide both by 5 to get 3/2. Oh wait, 3 divided by 2 is 1.5. So that's one way to figure it out. You could just do it in your head. So
Use the math button on the calculator too.
the math. Now we have it in a more familiar form. So I'm going to take the 2 and make it the index there. The 2 goes there, but I don't need to write the 2 because it's implied. And v cubed is inside. And there we go. The square root of v cubed is what we get. All right, please take a moment now to do letter C. Go. For this next problem, I want to show you real quick how to convert something. Go. I'm going to show you how to convert a number to a fraction. So for example, if I had 2.4 and I wanted to fractionize that, I can just press the math button right there. And if you notice here, at number 1 it says convert to fraction. So all I have to do is hit enter there or hit the 1, and now I get this on my screen. So when I hit enter, it'll tell me what my fraction is, 12 over 5. Good, so now I can put the 12 over 5 here. So a to the 12 over 5, and now that converts. The 5 goes there, and the a to the 12th inside there. All right, what about this ugly thing? What about this ugly thing? All right, beware for real ugly. This is, see what's nice about this is that it looks pretty cool, but this is the more the uglier ones. Okay, this is still my root. So I can still do square root. That means square root. And the rest of it goes in x to the negative 7. Now what does the negative exponent mean? It means I need to take whatever I have and drop it underneath. So now I have a 1 over x to the 7. So this actually gets quite ugly. So now continuing on, I can split the radical. So the square root of 1 is the square root of 1. And this one says the square root of x to the 7th power. Now, if you recall, when we were simplifying things like this, we're not supposed to have radicals in the denominator. So I have to get rid of all these in the denominator. I need to get rid of this here. So when you multiply it by itself, why am I multiplying it by itself? Because it's a square root. If it were a cube root, I'd multiply it by itself by itself. Whatever I do to the denominator, I have to do to the numerator. So I write that there. So here's what I end up getting. The square root of x to the 7 over x to the 7. Again, not very nice, actually. All right, how do we convert this last one here into radical form? Well, it's straightforward. Cube root of AB. That's it. Cube root of AB. So if we were to convert from radical to exponent, what would we do? So in this first one, notice there's a hidden 2 right there as an index. So all I do is have my base, my exponent there is 3, and my root and my index are the same. So x to the 3/2. Another thing we want to look at is putting things in simplest form. So these are going to use the power of the power of product, all these different properties of exponents. So notice here, the property of this exponent says, if you have what is called a power of a power, all you do is multiply your exponents, right? So this 1/4 times 4, 1/4 times 4 is 1. So there's my answer, 81. Well, how do I simplify part B? How do I simplify B? Well, there's a couple different ways to look at it, but it might be wise to reduce it like this, or to put it into radical form and have the square inside. Now, the square doesn't have to be inside. The square can be outside like we talked about. You don't have to write all these steps. I just want to show you conceptually what's going on. The cube root of 8, and then what we're going to do is square that. So what is the cube root of 8? That's something you can just plug into a calculator or you know in your head. So that's just 2. And then I bring down this 2 here to be squared. So my final answer is 4. All right, what do I do for this next one here? So that's going to be my 4th root of 1/16. So a couple different ways to approach this here. I can convert things to radicals. I can do whatever. So the whole thing can be, I can say this, the 4th root of 1/16 in my head. Notice also, if you point out, that 16 is just 2 to the 4th power. So the 4th root, watch what happens. The 4th root kills that 4th root. So in the end, the answer is 1/2. Or not, the 4th root kills the exponent, that's a 4.